Okay, in this video, we're going to look at some of the maths behind solving some simple trig equations. To begin with, I'm going to start with the equation sin x equals 0.3. And to the right of that, we have something called a domain specified, which in this case is the region that we want to find our solutions in. And so x has to be greater than or equal to 0 and less than or equal to 360. And you'll find in any question where you're solving a trig equation, there will always be a domain specified for which you're going to look for the solutions within. And so we could represent this solution graphically as follows. We could draw the graph of y equals sin x, and on the same set of axes we could draw the graph of y equals 0.3, just a horizontal line. And the first thing you might notice is that there are 2 points where those graphs intersect, and that implies this equation has 2 solutions. And you'll find that most of the time, if you're solving an equation of the form sin x, cos x or tan x equals a constant like 0.3, the equation will have 2 solutions in any 360 degree region, apart from in a few special cases. So let's call the first solution theta 1 and the second solution theta 2. And as we've seen previously, these 2 solutions are linked by the symmetry property for sine, which says that the second solution is 180 minus the first solution. And so the way we would often go about solving trigonometric equations of this form is we would first of all use our calculator to find a solution. In this case, we'd do inverse sine of 0.3, and then we would use the symmetry property to get a second solution. Okay, so sin x equals 0.3 had 2 solutions. Let's suppose we're given the equation sin x equals k in the same region as before. I'd like you to pause the video and have a think if you can find a value of k that would satisfy the conditions in A, B and C. Can you find a value of k that would give us 1 solution? Can you find a value of k that would give no solutions? And can you find a value of k that would give 3 solutions? Okay, pause the video, write down what you think, and then come back and check your answers against mine. Welcome back. Let's have a think about one solution first. We could draw a horizontal line across that looks like this, where it just touches the top of the curve but doesn't intersect it in 2 places. In that case, we would have the equation sin x equals 1, the maximum value on the sine curve. There's another place we could have put it as well. We could put it down here and solve the equation sin x equals minus 1. So those 2 are special cases where you'll only get 1 solution in a 360 degree region. Next, we'll think about the case when the equation has no solutions. Graphically, that's like saying, where can we put the line so that it doesn't intersect the curve? For example, we could put it at the top of the curve so that it doesn't intersect. There's lots of values that could give us that. For example, we could have sin x equals 3, but any value of k such that k is bigger than 1 won't give us any solutions. We could move the line below the graph as well, and so any value of k less than -1 would also result in an equation that has no solutions. Finally, we'll think about the case with 3 solutions. The only reason we can get 3 solutions here is because our inequalities are not strict inequalities. We've included 0 and 360 within the region. If we hadn't done that, it wouldn't be possible to get 3 solutions. The only equation that could give us 3 solutions is sin x equals 0, in which case it intersects the curve at 0, 180 and 360. So what I want you to take away from this is that if we have an equation sin x equals a number or cos x or tan x equals a constant, then a lot of the time we're going to get 2 solutions because that horizontal line will cross the curve in 2 places. But there are occasions where we might get 1 solution, no solutions, or if the inequality is inclusive of the endpoints, potentially 3 solutions within any 360 degree region. Obviously, if we change the region and make it bigger or smaller, that might affect how many solutions we're going to get as well.